We're going to talk for a few minutes about when crossover and straight-through cables are needed, why, and when in the real world you might not need one. That's going to go a little outside CCNA theory, but I will explain that when we get to it. It's something you need to know to be a real-world network admin. In this diagram, we have three connections: host to switch, switch to switch, and then switch to host. We need two different cables to make this work. And the first kind of connection we're going to address is the host to switch connection. We have two of those. And for those, we're going to use straight through cables. And they're so named because the 8 wires in the cable run straight from a particular pin at the host end, at one end of the cable, to the same numbered pin at the other end. So you're going pin 1 straight through to pin 1 on the other end, pin 2 straight through to pin 2 at the other end, and so forth. Now the chart I have up here explains why we use a straight through cable for this kind of connection. Your host, your PC in this case, is going to transmit on pins 1 and 2. Your switch receives on pins 1 and 2. So we're gold there, right? The PC is talking and the switch is listening to the same pins. As for these other two pins, 3 and 6, the switch transmits on 3 and 6. And the PC listens to 3 and 6. So, hey, it's a perfect relationship, right? We don't have to do anything with this, and we can just use a regular straight-through cable. And there's your straight-through cable data flow. Your host is talking on pins 1 and 2. Your switch is listening on 1 and 2. The switch is talking on pins 3 and 6. And the host is listening on pins 3 and 6, the PC. So we are all set there. Now, the problem comes in, or the challenge comes in, with that switch-to-switch connection. Because as we see by this chart, as a quick reminder, both switches are going to transmit on pins 3 and 6. Both pins are listening on pins 1 and 2. So if we use a straight through cable here, that ain't going to work. I mean, that is just not going to work, because they're going to be talking at each other on pins 3 and 6. And on pins 1 and 2, they're going to be listening for something that never comes. So what we need here is a crossover cable. And where we get that name is that the wires cross over from a particular pin number on one end of the connection to a different pin number at the other end. And I'll show you the numbers here in just a moment. But what this allows is that either switch can send a frame on one of its transmit pins, and thanks to the crossover, it arrives on the remote switch on a receive pin. So that's exactly what we want, and this is how that works. With the crossover cable, 3 goes to 1 and 6 goes to 2. So when the switch is talking on pins 3 and 6, the other one is listening on 1 and 2, and we're all set. That's all there is to it. But 3 to 1, 6 to 2, and then 1 to 3 and 2 to 6. That's the crossover cable. Now with Gig Ethernet, all 8 wires are used, and every wire can send and receive at the same time. That's 1000 base T Gig Ethernet, and that's a big reason that Gig Ethernet is Gig Ethernet to begin with. And there you go. So not only with a straight through cable are you using all 8 wires when it comes to Gig Ethernet, but there's also simultaneous send and receive on every wire. So you see how lightning fast that is as compared to fast Ethernet and regular old Ethernet. Now, if you built a Gig Ethernet crossover cable, it would look like this. And you see the way the wires cross from one end to the other: 1 to 3, 2 to 6, 3 to 1, 4 to 7, and then 5, 8, 6, 2, 7, 4, 8, 5. If you wanted to memorize this, great. If you put them together and you know them, even better. It's not something I would really be concerned about for the exam, but here's a real-world note that I want to give you as far as this goes, because it's something you should know for real-world networking, and it may well show up on your exam. It's something that allows you to use a straight-through cable for a crossover cable, and it's fantastic. But for the CCNA exam, unless AutoMDIX is specifically mentioned in an exam question, go with the theory that we've talked about for the last couple of minutes regarding straight through and crossover cables, and just forget totally about AutoMDIX. Don't read something into the question. If they don't mention MDIX, it isn't there. And just go with this simple rule. If they're the same devices, you need a crossover cable. Switch to switch, router to router, PC to PC. But if they're not the same type of devices, a straight through cable will do. Right? Right. Now with that in mind, let's chat about AutoMDIX and what the heck it is. If you've ever been in the situation where you needed a crossover cable and you didn't have one, give me a great big harumph right there wherever you are. Or you could just raise your hand mentally. Either one. But whether it's for a home lab or a client site, needing a certain cable and not having one, and you start digging in your bag a little deeper, thinking that God is going to put one in the bag for you. It is a horrible feeling, and that can happen in a home lab too, because you can be working away at something and you want to connect your switches with a couple more cables, and you look around and it seems like you never have crossover cables when you need them. Never, never, never. But you've always got straight through cables around. I mean, you got those, in your living room, in your kitchen, in the shower. It just seems like you've got those kind of cables all over the place. Well, that's where the automatic medium dependent interface crossover, thankfully abbreviated as Auto MDIX, comes in handy. Because what happens is when you connect a straight through cable in a situation like this, where between two switches, and if the ports you're connecting to are MDIX enabled, then the port's going to say, you know what, I know you meant to use a crossover cable here. I'm talking to the other guy and I can see he's a switch too. He's a like device. I got you back. I'm going to act like a crossover cable. It's a little more complicated than that in theory, I grant you. But if you want to look that up yourself, beautiful. That's something we're not going to go into here. It just works beautifully. And like I said, I've used it many a time, and you connect a couple switches and you didn't have that crossover cable and you're looking for one on Amazon, and you're calling your friends and seeing how fast you get one. But if you can use MDIX on your switch, then you are in great shape. To enable Auto MDIX on a Cisco switch port, and not all models run it, but it's if it does, then you need to set 3 things to auto on the port that you want to run MDIX on: speed, duplex, and MDIX. And I'm going to show you the config in a moment. If you're not familiar with Cisco config modes, hang in there, because we're going to cover them in detail later. We're going to be on live Cisco routers and switches, but I just want to show you this one on the board because it's how to configure a single switch port. And here it's Fast Ethernet 0/1, one particular port, or port 1 if you want to call it that, like I usually do. And I've set speed, duplex, and MDIX to auto. And that's what you have to do. It's just that simple. But again, on your CCNA exam, know when you need to use a straight through cable, know when you need to use a crossover cable, and knowing about this is a bonus. It's more for your job than for your exam, but I want you to know about it. Every network admin should know this exists, because if I leave this out too, I get emails and tweets all the time. It's like, hey, I put a straight through cable between 2 switches, didn't have a problem. And then say, okay, it's MDIX. Well, what's that? Well, I'll just tell you now instead of you having to ask me about it later. We will pick up on the next video by taking a much closer look at that Ethernet header and trailer that we looked at earlier in the course. I'll see you in a few minutes on the next vid.